This thing there. So cool. Online people. Anyway, I'm going to post it on YouTube. Okay, so we are back again. For those online, we're having challenge with the blender system, but follow me. What we're doing now is that we're trying to calculate the deflection angle. Is that okay? And the deflection angle is with respect to Ti. Remember, T is the tangent point, I is the intersection point. Okay, so assume we set up a total station and we pointed to the intersection point, then we can turn it to a point along the curve to be set out by the deflection angle. Okay, now as we do the deflection, calculate the deflection angle per point on the curve, we are also doing the cumulative as well, total deflection angle as well, because that's what the total station can turn. Are you okay? All right, so follow from where we've left it, and then I hope we get there. Okay, so what are we waiting for? What are you getting?
106.
Hey, you want something sweeter. This one is not one. Okay, so you don't know what to do with it, isn't it? You go over 60. You don't say 106. It's all right. What do you do, guys? What do? You take the 60 out of it, call it 1 minute, then the rest you see if you still have extra. Do you get it? 1 over something, isn't it?
Yes.
So see 60 out of that, that's one degree. Do you get it? Okay, so we have 1 degree. Then the remainder, so you need to do this kind of. Okay, you move to the second. So minutes, you get it. 60 seconds make 1 minute, 60 minutes make 1. So you write your answer always in that form. Is that okay? Waiting for you. So what are you having? My friend, what do you have? Hey, you be careful. What's your name?
I'm Maxwell.
Maxwell, be careful, okay? You think I've been teaching for years, maybe you can't see from me. My name is Samari, Prophet. I want to say, I'm a professor. Thank you. Yeah, literally, guys. Listen, I've repeated this. Let's not know. This is the calculation. And this cumulates or the total. Is that okay? This and this are the same. This yields the answers. Yes, the answer. So you can, if you can go straight to this point. It's all like yes. Literally, so I'm moving this. Saying this is what I move this line. That's what's happening. So, what do we have, guys? 4.8. Okay. So yes, we still have now. So we have 40 seconds, but you have 64 seconds. It's okay. It's off a bit, but it's okay. Yeah. Okay. How far do we go with this one? How far would we go with this calculation? Alpha. How many more do we need to do? When do we know when to stop?
When you get close to the teenage.
At you, yes. When you get close to the change at you, which we have already computed to what?
3.5.
So how many more do we have to do before we get close? I think this is just a tricky question, but do it. Try and do it for me. How many more of these 20s? I'm going to have 20, 20, 20. How many more?
Like 7.
That's 7, isn't it? Yeah. Because 7 times 20 is going to give it what? Don't 40 plus this, right? Are you all following or you know? 0, 2.
Yes.
So the next 20 will take us to 2 to 4, which is about this. So we work the difference, isn't it? All right. So what's that difference?
So between the
Between the 220 and coming here. Work that out. Please, we are doing something very interesting here. We are doing a final chord.
negative 15.5.
15.5. Do you know, right? How do you get this? You know, I think the new, right? Okay. So we say that we have to do this a number of times. How do you know the number of times you have to do this? How many times do you have to? See, don't forget that we are keeping intervals of what? 20. How many of them do we need to do before we go to the end? What do you say? What do you say? Always think about it. Okay? We are traveling. So now you understand? Yeah? How many of them do you need to get to the end?
Say, distance from the T to the middle.
It's a calculation. It's not a narrative. You don't have to narrate, do this, you get it wrong. Some questions are calculation based. You have to simply calculate, right? So my good friend, Said. Yeah, Said. How do we get to know how many times you have to do this intervals?
Once you get close to the change,
So how do we know it? We just go and how do we know?
keep adding 20 to the rate.
So you will just keep going. You wouldn't even know how many times you have to do it.
Like 7 times. 7.
I'm convinced. Okay, so let's so you understand why we get it now. The nearest round number to 20th multiple. Do you remember multiples of? So this is multiples of 20. Are you? Yes. So the nearest multiple of 20 here is what? 2, 2, 2, 0, isn't it? So, 2, 2, 0. The final, this is the change for you. Are you okay? Right, I'm talking to you. Am I talking to you? Are you feeling me? Feel me. Look at it. It means right there you can understand the change and running it to the nearest interval.
So that was what you was explaining to me.
The nearest multiple of interval. I don't know how to put this. Right? The nearest interval of multiples of the interval. You see how funny it is? That is how engineering is. Okay, very simple things, but you don't understand. I was telling someone that civil engineers are in charge of the waste management, but nobody mentions their name. I'll be the one. I'll go to one of these TV stations and I'll start mentioning the names of civil engineers. You do waste management, you find out you are in charge. So all the filth in the country is because of civil engineers. Don't say political role. Are you okay? So we should stop blaming. Are you okay? I know what's happening at Lands Commission. It's just the people they messing up system. People are getting killed. Are you okay? That's why it's messed up. Because people didn't calculate the right coordinates. Are you with me? Engineers have to be up and realize that we are solving a real world problem. Okay? Okay, so right, get it right so that we can move on. We are waiting for you. Bryce friend. What's your name again? Sorry. Chris, yes. Multiples of 20. Are you okay? Mhm. The nearest multiple of 2 for a value of 2.5 is what?
3.
No. So that's what we are doing. Do you get it? So very easy, isn't it? What's the nearest multiple of 2 to this number?
It's 2 itself.
Yeah, he's right, but it could have been 4, isn't it? Because it's 2.5 now. So you get it? 3.5, 4. Okay. So two there. You understand why we have it? Be honest, Chris. You get it? Eh? Let's explain to them. Tell them in the way that they will understand, because I think I've overdone it.
So I can still there multiples of or multiples of 20.
Yes.
Wow. The situation where you get 2, because the 10 we don't know the end, isn't it?
How did you get a 2, 2, 2? Isn't it? You don't know where
we are doing the thing so we get to the end, and now we don't know how many.
How did you get a 2, 2, 2? How did we get it?
Because we do the change to get to the change as we
Yes.
and the change as we
But we're not there, but we were able to know that the last change before we get to the last, the last multiple of 20 before you get to the change u is 2, 2, 2. It's math. Do you get what I'm saying?
Yes, sir.
The same thing we're doing with the 1.5 and all that. Multiples of 2, 4, 6, 8. You get it? Right? So if I'm at 4.5, what's the next multiple? Are you okay? Or if I want to get to 4.5, what's the previous multiple? In this case, to get it. If I want to get to 4.5, what is the previous multiple to 4.5? Okay, let's do. What's the previous multiple of multiples of 10 to 90? Previous multiple of 10 before you get to 90. You get that? So previous multiple of 5 to 42 before 42. The previous multiple of 20 before 2, 2, 2, before, isn't it? That's why we got it. Okay, so you have to pay me for this lesson here. Okay? This multiple. Let's start with it. Okay, but you get it, right? So the last chord, what's the final chord? So what's the final chord then? The final chord is going to be. So we now know the initial chord. You know the final chord. Are you okay? I know the intermediate chords are what? 20. End of story. Okay. All right. So maybe we can even do the very last one. So the last change will be this one. Are you okay? All right. So 15.5. All these are 20. 1718.9 and 15.5 plus 20. Do this calculation, but of course you wouldn't know the previous one to be a calculation, but just do this one. That's the last one. Okay. What do you have? How do you check that these values are correct? How do you check that chords that you've calculated are correct?
without all the chords.
Then it should be equal to
The long chords. T.
the length for the curve. Did we get this one too? So we're not doing it. Or do you want us to do it? I mean, it's just repetition. Are you okay? We'll do it. All right. If we did it, then we can do it. If you're not going to do it, it's okay. Okay, I'm moving. I'm cleaning the board. I'm going to talk about setting our coordinates. It's okay. I'm cleaning it up, okay? Okay, so we have a situation like this. This is the one. Okay. Oh, my lady, I see your board, eh?
Yes.
You should go a bit faster, should we? The place is hot, and that's what makes you feel sleepy. Are you okay? Please, can you put on? Someone is about to sleep. This is the north. I hope you know what the north is, right? That's the north. I'm just going to explain how all the other things do. Okay. Here is the bearing of the line. This is the bearing. So example, let's see 3 degrees, 27 minutes, 14 seconds. I think it makes sense, isn't it? So that's a clockwise bearing. So if you have, these are the cardinal points, no, this we can even call this one X and Y. So if you have a point here, A, a point here, B, the bearing is this one. If you have point A to C, the bearing is this one. Okay? So I get that. If there's another point here, D, then the bearing is from. So this is the north. I get that. So that the Y is like. So it's the various point the Nordics. Excuse me. The Nordics. The Easterns are, so the Nordics are Y. The Easterns are what? X. Okay. Which is things like basically to you. If you have a bearing in here, it's in the fourth quadrant. So this first quadrant, second quadrant, fourth quadrant. Are you okay? You're supposed to know it. Okay. But I'll still do it. When you get to bearing, that's the bearing of it. It's between what? 180 and then 270. Are you okay? And then vary from here to here is what? Between 270 and 360. Are you okay? So by looking at the bearing, it tells you. So here in this case, 63 degrees, falls between 0 and 90. So we know the line, the bearing is going this way. If you know the line. Are you understand? Wait, so now let me just draw a few things that are important to you right now. So you have a point here. It's a point that defines the point C1. That's why this one C2. Is okay. Then we can draw a line with the chord. This is the chord. I have CC1. So chord CC1. Okay. And then this chord is actually what? C1, C2. Is that so? Yes. Right. So the idea is that we want to actually compute the coordinates for the points. Okay. The idea is that some total stations allow you to set up. You can just load the coordinates into the total station. And then now it will just set out where the point should be. That is the main idea. Yeah. All right. So now we are interested in two sets of angles. We're interested in the deviation of this line. Okay. For this chord, the deviation of this chord from this chord Okay. So this line here changes in direction, isn't it? So we can actually continue it. I don't know. It has kind of changed direction. I don't know. Let me take my time and explain this one. There are two sets of angles I want to look at. So let me just get it well for you. So we have one angle like this. So if you went this way, we can have these ones as alphas. Are you okay? So call this alpha 1, call this alpha 2. Are you okay? So alpha 1 intersects the curve to define the first chord point. That's what chord point C1. This is going to form C2. Are you okay? And we can carry on to get to the last point. Okay, so I want you to first appreciate alpha. Are you okay? It's like clap for head. Okay, and then now we are coming to lambda. So lambda is quite tricky. Lambda is a deviation of the chord. So if the chord were going straight, okay, how far has it deviated from that? That would be called lambda 1. Okay, so lambda 1, are you okay, has a relationship with the change in direction of this chord. The chord goes this way, and that's that. Are you okay? So it's like one chord goes, so because it's curving, that's that. How much has it changed? That is lambda 1. Meanwhile, alpha is the angular distance between the first, direction to this point, and then that one. First appreciate, then we move forward. Is that okay? So do you appreciate it? Look at it, just study it. Okay? So the deviation between this line we're not having, this line will have gone straight. Okay, now let's introduce C3. So who can come and show me what lambda 2 is based on what I've explained? So if you don't understand it, let me go back and let's talk about lambda 1. Okay. We want to just calculate the coordinates as well. See what we can coordinates for T, Q, I, okay. That's our objective now in this section. So we can set out from long chord, from the tangent. Okay, can set out with what? Deflection angles. Okay. Is this our second meeting or third? This is our third meeting. First meeting was introduction. Okay. Second meeting was horizontal curves, traditional method. Are you okay? From long chord, from tangent. Okay. Third meeting, what have we looked at so far? Using the chainage, okay, and then the deflection angle. Are you okay? Calculating the deflection angle. Now, here's where we are. We are now defining two parameters. Alpha 1, which is it's like a deflection angle. I'm going to do the but it's basically like that. Are you okay? This alpha 1 is a deviation from the line joining the tangent to the intersection point. Are you okay? Remember, I'm not drawing this. It's there. I'm not drawing it. When we are teaching some things, we are focusing on this. 1, 2, 3. Okay? What is lambda 1? Is the deviation of the chord itself from the previous one. So we are going to have lambda 2, lambda 3, lambda 4. We are going to have a lot of C0 to C3 per the chord distances as we described earlier. Okay? So if you understand what I'm saying, can you come to the board and then show me what lambda 2 would look like? If you don't get it, just say, if you get it to tell me so that we move forward. Easy. And if you get it wrong, hey, you are too close to me. What? Exactly. That's the one. That's it. Thank you very much. Please, I hope you follow. So I'll ask you to come and do C3, right? C4, right? Okay? So I ask you to come and you'll be able to do it, won't you? All right. So then we cannot, we have this point, so we can now put, we have alpha, I get that, alpha 4, C4, lambda 2 has a relationship with alpha 1 and alpha 2. I get that. Try to just appreciate it because I'm about to we're just about to do some calculation on that. Is that okay? If you don't understand it, just ask me a question. But you should understand it. Just differentiate between the lambda and then the alpha. Yes. What do you think that? What do you think we are trying to do? We have alpha with reference to I. What do you think we are trying to do? If I know the bearing of a line like this, and I measure an angular distance like this, what am I doing? I'm trying to get the bearing for this one. If I know the bearing of a line like this, and I find this angle, are you okay? Simply what I'm doing is that I'm trying, since I know the bearing here, I'm simply trying to do alpha 1 plus xi to give me the bearing of C1, IC1, get it? What does that help me to do? I'm able TC1. I'm able to now calculate the coordinates of point C1, which is my objective. If you understand it, this is the lecture. I can walk away. Are you okay? Oh, it's true. The rest that we do on the board, I'm teaching, and I'm a lecturer. Are you okay? Don't try to bring me down. If I'm able to convince you what I'm doing on the board, that's called lecture. I'm done. Are you with me? But it's your understanding that is important when you come to the lecture. It's not anything else than to understand what is really going on. Are you okay? If you don't know bearing, that's another thing altogether. Bearings are measured with respect to the north. Okay? So, and the north kind of coincides or synonymous with the y-axis. Okay? So what we know from any level of education to be y is actually north. Okay? All right, wait. Please, do you understand this level thing I've done? You do? Let's move. Okay. Let's assume that we have this to be the bearing of line TI. Is that okay? Let's move. I'm gonna make use of some data. I think I need to give you some data. Okay, now take this down, or maybe just take note of where these things. Just write these things down. The circular curve designed in the previous worked example, so I'll give you data from that, is to be set out by intersection methods. The circular curve designed in the previous worked example, and as I said, I'll give you the parameters. Is that okay? Is to be set out by intersection methods from two nearby traverse stations. The circular curve designed in the previous worked example is to be set out by intersection methods from two nearby traverse stations A and B. Full stop. The position of the tangent point T is set out on the ground position of the tangent point T set out on the ground and its coordinates are obtained by taking observations to it from A and B. When you are given a question, you should know which one is chaff. Is that okay? Right, let's move on.
So this coordinate is
And its coordinates are obtained by taking observations to it from A and B. When you are writing, you can't feel sleepy. Full stop. Observations taken from T to the intersection point I. Observations taken from T from the intersection point I. Enable the whole circle bearing. Observations taken from point T to the intersection point I enable the whole circle bearing of TI to be calculated as what we see.
the observation from
Taken from T to the intersection point I enable the whole circle bearing. The whole circle. So whole that circle. These are the other types of bearings. So these are WCB. Okay. This type of bearing always references to the north. Right? So it doesn't matter where you are. So you get 0 to 360. Is that okay? As opposed to there's a certain bearing where you refer to the cardinal points. I have 2 degrees south, 2 degrees southwest. You know what I'm saying? That type of bearing. Remember that. This circle bearing. To be calculated at 63 degrees, 27 minutes, 14 seconds.
20.
The coordinates of A, B, and T are are you there?
So the calculation
To be calculated at 63 degrees. It's on the board. 27 minutes, 14 seconds. The coordinates of A, B, and T are as follows. A, B, and T are as follows. So I should now give you the coordinates. Let me just write them. C, A, B, and C over here. They're getting typographic errors in this place. A, B, and T. I get A, B, and C. So T is 798. Okay, so can you imagine they were doing typographic errors in the textbook? This is British. Seriously, I mean, I can't believe this. Anyway, they say A, B, and T, but you see A, B, and C. Is that okay? So online people, take note of it. The session will end in 7 minutes. When it ends, please rejoin. Okay, so these are the coordinates. A is 829.17 meters eastern, 724.43 meters northern. B. The thing with the fun is that it dries up the marker. 915.73 meters eastern. I've already explained eastern and northern to you, so you know what they are. I think you know them already. Even before this class, you know them. Meters northern. Then what is calling C is actually T. I can't believe this. So please, guys, be careful. Is that okay? Today I'm really convinced that there are mistakes in some of these materials. You need to just understand the concepts. Don't follow anything. Don't trust any textbook. I've never said it before, especially a British textbook, because they claim to be very meticulous, isn't it? Okay, using the relevant data from the previous work example. So let me just look at the previous work example and give you some information on that. So this one, by the time we finish writing the questionnaire, the time will be up. Initial subcode. Write it down. So write this down. When it's done, I'll give you the initial subcode. But let me tell you the truth. Once you understand it, so I'm going to just do one calculation. You understand it? Then I'll assume that you can do the rest. Is that okay? We like do the C1. All this was C1. Then we done. Okay. Then it means you can follow and do the rest. Okay? So do you have these coordinates down?
Yes.
Okay. Write the initial subcode 24.06. Write it down. 24.06. General code. So you know what the general code, I want us to repeat it. 25 meters. It means the interval is what? 25. Final subcode. 14.87. Final subcode. 14.87. Yes. Chainage. Okay, do we even need chainage? We don't. So let's just move on. If we need it, I'll give you that. Is that okay? Right. The radius R is 600. All right. Excuse me. So can we calculate the cumulative angle for C1? So I want us to, since we know how to do it, let's calculate the initial. Let's just do it, just to see if you understand, you remember what we just did. What we just did now, we're doing it again with this data. What's the cumulative tangential angle for the first point C1? Okay, what do you need to do that? I'll give you the chords, haven't I? So you can do it. You can, right? What's the formula for alpha? Alpha is equal to 1718 times C over R. I do that for me. What is C for the first peg? The first peg we are putting the C is what is the chord length for that? Just giving it to you, yes. Just giving it to you. So try and work out that just so that we can all be on the same page. Is that okay? Bless you. What are you getting? It's looking promising. Yes, carry on. Very good. You are close. Perfect. Perfect. Very good. So that value that is getting is alpha 1. Is that okay? So alpha 1 degree size 1 degree.
1 degree, 8 minutes, 56.
So that's bang on. This one, there's no error. Okay, that's what we want. What is then the bearing of T? T1. So we are pointing at it. Are you so we are setting it's really you just have to say that's what we need to do some math. So then Ti is 63 degrees. It's 7 minutes 46. So therefore very TC1 is equal to 63 27 minutes 46 seconds plus 1 degree 8 minutes seconds. Let's write this right now. Our focus is to calculate the volume at C1. Stay with me. So let's do that. I'll do this soon. It's our action focus. I only had it here. What do we get for this? So use this as practice so that you know how to add rules. Okay, like I said, I won't do a special tutorial. This is tutorial lecture. But you're not doing it. You're saying, okay, you do calculate. Further.